Alcohols. Alcohols contain hydroxyl group bonded to tetrahedral carbon atom. This is the structure of alcohol. This is the carbon here. It's a tetrahedral carbon. It's a hydroxyl group, and also has this carbon has 3 bonds to either another carbon or hydrogen. This is the alcohol structure. Alcohols are classified as primary, secondary, and tertiary based on the carbon atoms bonded to the carbon with the hydroxyl group. Primary alcohol, the hydroxyl bonded to carbon bond to one other carbon. This is the primary alcohol here. This is the carbon bonded to the hydroxyl group. They bond another carbon here, and another two is the hydrogen. This is the primary alcohol. The secondary alcohol, the hydroxyl group bonded carbon bonds to 2 other carbons. This is the secondary. This is the carbon bonded to hydroxyl group. Then this carbon has 2 bond to other carbons here. So this is a secondary. The tertiary, this hydroxyl group bonded carbon bonds to 3 other carbons. This is 3 other carbons. This is the tertiary. Now alcohol has a dipole. Alcohol exhibits intermolecular hydrogen bonding. This is the dipole. Two polar bonds. This is oxygen. This hydrogen is a methyl group. So oxygen has higher electronegativity than carbon and hydrogen. So the 2 polar bonds. It's the dipole. The oxygen side are partially negative, and the carbon and the hydrogen side are partially positive. This is the dipole here. Physical properties. Alcohol have a higher boiling point and a melting point because it has a hydroxyl group, the hydrogen bond to oxygen, so they can form hydrogen bond with other alcohols. So alcohols have higher boiling point and melting point than hydrocarbons of comparable molecule weight and shape. Basically, alcohols have higher boiling point and melting point than the organic compounds that cannot form intermolecular hydrogen bonding. Alcohols are soluble in organic solvents. Low molecular weight alcohols, less than 6 carbons, are soluble in water. High molecular weight alcohols, 6 carbon or more, are not soluble in water. This is the physical properties of alcohol. Next, let's take a look at how to name alcohol in the AUPAC system. This is the steps. First, the alcohol ends with OL. Find the longest, second step, find the longest carbon chain containing the carbon bonded to hydroxyl group. In this example, you can see the longest chain is this is 6 carbon chain here. The number 3 here, C3, has a hydroxyl group. The step 3, number the chain give the hydroxyl group the lowest number. So this chain is we call it the hexagonal, and then we count the carbon numbers from this side. They give this carbon number 3. If we count from this side 1, 2, 3, 4, they give this number 4. So therefore we have to take the lower number and count from this side. So this is called 3 hexagonal. It's hexagonal, the 6 carbon alcohol. Number 4, follow other rules of naming hydrocarbons. In this molecule, you can see carbon 5 bonded to a methyl group. So the full name of this compound is called 5-methyl-3-hexanol. When a hydroxyl group is bonded to a ring, the ring is numbered, beginning with the C1 bonded to the hydroxyl group, and 1 is omitted from the name. If this if the molecule, this alcohol is a ring, and the carbon bonded to hydroxyl group is named as is numbered as C1, and when we name it, the 1 is omitted from the name. The ring is numbered to give other substituents the lower number. This is the 2 examples here, and this one is a methyl cyclohexanol. Hexanol is a 6 carbon alcohol. It's cyclo, it means it's the ring, and 3-methyl, that means at C3 has a methyl group here. So we number from this C1, C2, C3, C4, C5, C6. This one is 2-ethyl cyclopentanol. Pentanol means this is 5 carbon alcohol. Cyclo is a ring, and 2-ethyl, that means at the C2 position we have ethyl group here. Then take a look at the common names of alcohol. First, name all the carbon atoms of a molecule as a single alkyl group. Add the word alcohol follows the alkyl group and separate by space. This is the example. This is a 3 carbon alcohol. Is a propyl. This is the alkyl group. A propyl. Then using the separate word alcohol is propyl alcohol. Compounds with the 2 hydroxyl group are called diols or glycols. Compounds with 3 hydroxyl group are called triols. To add a diol, this suffix diol is added to the name of the parent alkene, and the numbers are used in prefix to indicate the location of the 2 hydroxyl groups. Let's take a look at the reactions of alcohols. The first one, dehydration. When an alcohol is treated with a strong acid, such as sulfuric acid, the elements of the water are lost, and alkene is formed. An alkene is formed. Dehydration is a type of elimination reactions. Elimination is the reaction in which elements of starting materials are lost and the multi-bond is formed. Is a starting materials. Take a look at this. This is the ethanol, and the lost water molecules become ethane, and the double bond formed. This is the water molecule. Sometimes more than one alkene can be formed as the product of dehydration. Take a look at this. This is a butanol. Butanol has 4 carbons, 1, 2, 3, 4. When this molecule loses the water, so it depends on which hydrogen it takes. In this case, this hydrogen at C1 and this hydroxyl group at C2 are eliminated. They form a butene. This double bond is between C1 and C2, so this molecule called 1-butene. This one is different. In this same molecule, but in this reaction, and the hydrogen at C3 and the hydroxyl group at C2 eliminated. So the product is called 2-butene because the double bond is between C2 and C3. Next, let's take a look at Zaitsev rule. Zaitsev rule means the major product of elimination is the alkene that has more alkyl groups. In this situation, you can see the 2-butene has 2 methyl group, and the 1-butene only has 1 acyl group. So, based on the Zaitsev rule, the 2-butene will be the major product because they have more alkyl groups, 2 methyl groups. This one only have 1 alkyl group, is an acyl group. The last, let's take a look at the oxidation of alcohols. Oxidation results in increase the number of CO bond or decrease the CH bond. Organic chemists use the symbol, this symbol, the O in brackets, to indicate oxidation. Oxidation occurs by replacing the CH bonds on the carbon bearing the hydroxyl group by the CO bond. So all oxidation products from alcohols contain the carbonyl group. So this is the oxidation. This hydroxyl group in alcohol, and the this alcohol is oxidized, become a carbonyl group containing compound. The general scheme for oxidizing the organic compound is here. And the starting material has 4 CH bonds, the methane in this case, and 0 CO bond. The first oxidation, they generate 1 CO bond and decrease the CH bond by 1, and this one they increase another CO bond. This becomes 2 CO bond here, also decrease CH bond by another one, and then this third one, another CO bond increased, and the CH bond decreased, and eventually the final product become no CH bond, 0 CH bond, and a 4 CO bond. It's a 4 CO bond. Primary alcohols are first oxidized to aldehydes, which further oxidize to carboxylic acid by replacing 2 CH bonds by CO bonds. This is alcohol, the primary alcohol, and become oxidized into a carbonic compound, then carboxylic acid. The secondary alcohol are oxidized to ketones by replacing the CH bond by 1 CO bond. The carbon bond bonded to the hydroxyl group bears only 1 hydrogen. Only 1 product is formed. That's the ketone. And the tertiary alcohols have no hydrogen bond to the carbon. No hydrogen bond to the carbon bonded to the hydroxyl carbon. That means this carbon, then no hydrogen, so they cannot be oxidized.